3I Atlas is on its way towards Earth. But where did it come from? Is it a comet? An asteroid? An alien probe? Imagine a star system, ancient beyond human comprehension, forming in a different part of our galaxy, perhaps in the Milky Way's thick disk, where the oldest stars reside. For billions of years, long before our own sun and planets even existed, the primordial object we now call 3I Atlas was born from the cosmic dust and gas of that long-extinct star system. Estimated to be over 7 billion years old, 3I Atlas is a true relic, a silent witness to the rise and fall of countless stars. At some point, a massive gravitational interaction, a cosmic slingshot from a nearby star or planet, ejected 3I Atlas from its home system and into the vast, cold emptiness of interstellar space. For eons, it drifted, a lone nomad traveling at an immense speed of over 130,000 miles per hour, a velocity far too great to be captured by the gravity of any single star. This extraordinary speed is a signature of its interstellar nature. Our story of 3I Atlas officially begins on July 1st, 2025, when the NASA-funded Atlas Asteroid Terrestrial Impact Last Alert System Survey Telescope in Chile first spotted it. Initially, 3I Atlas displayed clear cometary activity, a key feature that was missing from Oumuamua, the first recorded interstellar visitor to our solar system. It has a distinct coma, a glowing cloud of gas and dust surrounding its nucleus, and has even shown a faint tail. Yet, early spectroscopic data revealed a reddening of its light, similar to a D-type asteroid, and a lack of the typical gas signatures found in solar system comets. This sparked debate over its true nature. The leading theory? It may be a highly volatile comet with activity triggered by exotic ices rather than water, but Harvard astrophysicist Dr. Avi Loeb believes the unusual sublimation could suggest something more. Alien technology. Since then, a global network of observatories from the Hubble Space Telescope to Gemini North have locked onto 3I Atlas, revealing some of its most intriguing characteristics. Refined observations from Hubble indicate its icy nucleus is at most 3.5 miles or 5.6 kilometers across. Though smaller than early estimates, it still dwarfs Oumuamua's mere 0.2 miles and Borisov's 0.6 miles, making it the largest interstellar object ever discovered. 3I Atlas has an improbable trajectory and appears deliberate. Our first two interstellar interlopers, Oumuamua and 2I Borisov, arrived from random steep angles, typical for cosmic transients. Interstellar objects can enter from any direction, unbound by the flat disk that shaped our solar system billions of years ago. As we can see, in 2017, Oumuamua entered our solar system from above, on a steep, hyperbolic path that sliced through the planetary plane like a cosmic dagger. It didn't orbit the sun, it slingshotted around it and accelerated out, faster than it came in. It showed no signs of gas or dust, just a long, tumbling shape, unlike anything we've seen before. Then came Borisov in 2019, a more familiar sight, a true comet, active and volatile, with a bright coma and tail, but its angle was just as steep, rushing through the solar system on a trajectory that ignored the orbits of our planets. No attempt to stay, just a fast-moving fragment of another star system passing through. But 3I Atlas didn't behave like a random visitor. It approached remarkably close to the plane of the ecliptic, the orbital plane where most of our planets reside. The odds of this happening by chance? About 1 in 10,000. But the improbability doesn't end there. Besides Earth, 3I Atlas will have close encounters with Mars, Venus, and Jupiter. The odds of a single interstellar object encountering these specific 3 planets in such a sequence are estimated to be tens of thousands to 1. What force or what intelligence guided this interstellar scout through our planetary neighborhood with such precision? Could it be a silent probe scanning for signs of life or a new world to call home? The brightness paradox. One of the most perplexing aspects of 3I Atlas is its extraordinary brightness. At the same distance from the Sun, it shines an astounding 251 times brighter than interstellar comet Borisov. Normally, a comet's brightness is linked to outgassing, volatile compounds releasing gas as they heat near the Sun. But here's the twist. Intensive spectrographic analysis shows no conclusive evidence of typical outgassing. No definitive signs of water vapor, no carbon monoxide, nothing we'd expect. A paradox, 3I Atlas is a brilliant comet, yet not behaving like any known comet. The mysterious glow in ancient history. Adding to the mystery is a strange glow observed ahead of 3I Atlas's nucleus. Scientists believe this could result from microscopic fragmentation, its surface slowly eroded by collisions with interstellar dust over billions of years. This glow may be the visual scar left by time itself, a sign of just how ancient and battered this traveler truly is. The most troubling feature, a teardrop-shaped coma. Unlike the symmetric comas of solar system comets, 3I Atlas exhibits a teardrop-shaped coma, its dust concentrated toward the Sun, asymmetric and unstable. This suggests a rotating nucleus with uneven jets or a porous structure venting gas from one side. In many comets, teardrop comas are a final warning. They often appear in comets nearing disintegration. And if 3I Atlas breaks apart, its extinction-sized fragments could be hurled across space, one day possibly crossing Earth's orbit. Dr. Avi Loeb has suggested a chilling possibility. The teardrop shape may not be a sign of disintegration, but of control. Alien technology intentionally directing the dust tail toward the Sun, possibly to slow 3I Atlas for a controlled approach into Earth's orbit. What does all these facts add up to? A unique interstellar signature. While 3I Atlas dazzles us with brightness and improbability, it invites comparison to our first interstellar visitor, Oumuamua. That object's most baffling trait, it accelerated without any visible propulsion, a non-gravitational acceleration still unexplained. Could Oumuamua have been the first probe? And is 3I Atlas the follow-up contact, sent by a civilization 7 billion years old? The James Webb Space Telescope, JWST, has joined the global effort, beginning its observations of 3I Atlas in August 2025. A second observation window is scheduled for December after it passes its closest point to the Sun. Using infrared spectroscopy, JWST will search for specific compounds: water, CO2, ammonia, carbon monoxide, clues to origin, clues to purpose. Will JWST uncover icy compounds or expose the absence of everything we expect? And if so, what exactly are we looking at? By December, we will have the most up-to-date information. We will know if 3I Atlas is an ancient interstellar wanderer, an alien probe, or a comet on the verge of destruction. The latter two scenarios hold very ominous prospects for humanity. If Dr. Avi Loeb is right, we could face subjugation by a superior alien race. Or if 3I Atlas has an unexpected course change or breaks apart, it or any of its extinction-level fragments would devastate our planet. A direct hit by 3.5-mile-wide interstellar object traveling at 130,000 miles per hour would in a single instant ignite the sky. The atmosphere would flash to plasma, mega tsunamis would engulf our coastlines, and within minutes, our world would change forever. Can we survive an actual visit by 3I Atlas? NASA has confirmed 3I Atlas is not staying. Its hyperbolic trajectory ensures that it's not gravitationally bound. It will pass once, then vanish into the dark. 3I Atlas's closest approach to the Sun is October 30th, 2025, just inside Mars's orbit, its closest distance to Earth, 170 million miles away. It will never return. Yet in its brief passage, it may reveal more about the galaxy's ancient past than any probe humanity has launched. Where does it go now? Perhaps it drifts endlessly between the stars, or perhaps one day, light years from now, it will brush past another young world, just as it has brushed past ours. A messenger without a message, a riddle without a sender. If you enjoyed today's video, hit subscribe, ring the bell, and join us as we decode the universe, one shadow at a time. Comment your theories below. And remember, the truth is out there, and we may not be alone.